To wrap up our discussion of nitriles, we're going to look at some ways they can be used in the synthesis of molecules. And the thing I want you to keep in mind as you do this is if you're adding a single carbon to a molecule, a nitrile is often a good way to do that. Just remember, if you're going to add a CN group through like an SN2 reaction, you do need a good leaving group in your molecule. So in this first example, we have this allylic bromide, and we're converting it to an amine, but what you should immediately recognize is you're of course adding a nitrogen, but also we're adding a carbon. So we're adding one carbon to the chain. We're going from 3 carbons to 4 carbons. So nitrile chemistry is likely a good way to do this, and specifically, since we also need a nitrogen, that also leads us to believe a CN is a good way to do that. So what you would want to do first is add sodium cyanide to do the SN2 reaction. So that will add here, displace the bromine. All right, be careful. A lot of people will then just write CN. But what you've done is you've gone from something with 3 carbons to a product with 3 carbons, yet you're adding the CN. So be careful, draw out the extra line to show the bond to the cyano group. From there, now all we need to do is reduce this nitrile to the amine. So there's 4 carbons, the same 4 carbons. To do this, just add LAH, followed by an aqueous or acidic workup. In this example, it's written a little bit differently. We're using the retrosynthesis arrow. Which basically just says, how do I make this from this? Plus you're given the stipulation, you can use any other reagents as long as the reagent has 2 or fewer carbon atoms. So when I look at this, I see first that all of this portion comes from this molecule here. But I'm somehow adding these 3 carbons. Well, remember, nitriles can be converted into ketones, which is what we have here. So maybe this carbon right here can be added via the nitrile. And then add the ethyl group via the Grignard. So working this in the forward direction, start with my organohalide, add NaCN, and that adds, I've now incorporated the cyano group. Then from there, now we want this carbon to be this ketone carbon. So all we need to do is add the Grignard reagent. We want the ethyl group added, so add ethyl magnesium bromide, followed by H3O plus. And that gives us our product. This third example often trips people up because we're going from a carboxylic acid to a carboxylic acid, and people often think, well, this carboxylic acid must be this carboxylic acid, so how do I somehow stick another carbon into the chain? What I want you to remember is that the carboxylic acid here can be converted to something else. That can be converted to a nitrile to add a carbon, which can then be reconverted to a carboxylic acid. So this carbon is still this carbon here. The carboxylic acid carbon we can add via the nitrile. But if we want to incorporate a nitrile, we need a good leaving group on this carbon I have in blue. It takes a couple steps, but with reactions you can do that. The first thing we want to do is reduce this to an alcohol. We need to use LAH for that, followed by, you can use water or acid in the second step. And I'll keep that carbon highlighted in blue so we can keep track. Now we have the alcohol. From here, you have a couple of choices to make that a good leaving group. You can use tosyl chloride and pyridine, that works just fine. Make it the tosylate, or you could add PBr3 and make it the bromide. Either's perfectly acceptable. Let's just stick with the bromide here. Now that we have the bromide, this is a good time to incorporate the cyano group. If I add sodium cyanide, now we've incorporated that CN. And let's just put a dot on the carbon in green to say that that carbon becomes this carbon. From here, now that you have the cyano group, we know that we can hydrolyze that to a carboxylic acid by adding acid and water. Once you do that, you get the carboxylic acid, and we've extended the carbon chain from, we have the phenyl with 2 carbons. Now we have the phenyl and 3 carbons in the chain.